There we go. Welcome to episode 69. We're going to talk about performance and libraries and Reactive and all that kind of stuff. But before we go to our guests, two news was we had the Quarkus 2.4.1 out last week with a bit of bug fixes. And 2.5 is coming 2 weeks, next week? I can't remember.
2.5 CR1 will be out this week.
That's how it was, yeah.
So let me paste the link for planning for everybody to see whenever they want. This week, CR1, and then final with the platform probably a couple weeks.
And then Quarkus is compatible with Java 17. It's been for a while. And we even have a talk about it. But one thing that's been challenged is the native support. And we actually have GraalVM 20.3 has Java 17 in there. But we do know there are some issues, but we are looking for everyone who wants to try give it a try. So if you're trying out GraalVM, please let us know if it works for you, and especially if it doesn't. There are some known issues that we need to kind of tweak for native. Any comments on that one, Clement?
Well, about the second one, yes. So we know that there are some issues. We need to adapt a little bit what we do in Quarkus, especially some of our substitutions that use things that have been gone or removed in Java 17. So give it a try, report any issues you see, because we really want to have a native Java 17 support. Yeah, so give it a try, report issues, we will fix them. I already found 2 this morning. I'm pretty sure that you will find others, and we can fix them quickly before 2.5.0 final. That would be great.
Do we actually? One thing I saw was a couple of people asking for Docker images for 17. We don't really have a. Do we have one?
It's coming.
It's coming, yeah. Okay.
I think there is a release date around November 6th or something like that, which was last week, so I need to check if it has been released or not.
It's going to be there very close. So, yeah. So you can run, you can use Quarkus with Java 17. There's just some with Java 7 native Java 7 native. Native Java 17. There are some challenges, but we work on them. Cool. Well, let's get on to the interesting part. So, Julien, you've been on before, I think. I can't even remember.
Oh, no, it's my first.
It is your first time.
Yeah, first time here.
Got it. Well, okay, then introduce yourself. Who are you and why?
If only I knew. So I'm Julien. I'm working at Red Hat. I'm a principal software engineer. I've been working in the Vertex team. I also contributed to Quarkus, and these days I'm spending lots of time on Mutiny, which is something we're going to talk today, which is a reactive programming library for Java, which is used in Vertex and Quarkus in our stack.
And come on, you're not going to tell us you wrote a book about Vertex, the book about Vertex?
I was going to think about it and take my 1 minute of shameless plug. So yeah, I wrote a book called Vertex in Action at Manning, which is a great book, obviously. And if you have friends, for Christmas, you don't know what to offer for your friends or family, it's a good investment. You can probably buy it as an NFT on the blockchain if you want. That's fine. Just buy it if you want.
There we go. Okay. Well, yeah, and just so we actually had, I lost track, but 2 episodes ago we had Hibernate Reactive with Gavin and Sanya on, and we kind of continuing that path of talk about Reactive. And this time is, I don't know how to describe it, but you guys, you wrote a paper or co-wrote a paper. I'm going to put that in here, a link. There's even a nice video, but I think you might cover some of that stuff now. But we thought it'd be interesting to kind of talk about what you found in that paper about different reactive frameworks, because it is a bit of a hot topic, and maybe explain the reasoning why in Quarkus we have done things differently than maybe others have done. So Julien, did you want to give a overview of what's there, and then for anyone who's listening, ask any question in chat. And the idea here is to get a conversation going, and say, hey, that's not what we experienced, or this is what we experienced. Why is that? And when to use Reactive, when not to use Reactive, etc., etc.
Sure. So if some of the attendees need some context about what is Mutiny, what's reactive programming, I can show some code examples if need be at some point.
Yes, code is good.
Code is good. So yeah, I have a text editor which is ready if you want to show something, and it won't crash because it's not a development environment that's going to stop in the middle with I'm indexing the world and I'm just stopping everything. Cool. So we can run the demo. So yeah, so the topic of today is that paper we wrote with. So we are actually four authors, 3 redactors, and a friend from. Which is a former colleague from my former research team, Frédéric Lemoel. So there is Clément, Arthur Navarro, who's doing research with us at Red Hat, and Frédéric Lemoel, who's a professor at INSA Lyon in France. So we wrote this paper to discuss the relative performance of the of the popular reactive programming libraries in Java. So namely RxJava, Reactor, and Mutiny, which is the most recent one, and we wanted to to see, is there any performance benefit in choosing one or the other, or what gives. And it's so to provide a little bit of context, we started doing these investigations because I joined Mutiny like a year and a half ago, something like this. Clément, am I right?
Yes, something like that. Yeah.
So I joined you on this project, and what I actually enjoyed when I started working on Mutiny is that the code base was, I wouldn't say simple because implementing reactive programming libraries is complex, but it was approachable. So you could understand the bits and how they work together and how they fit together. And like in a week, I was able to make changes to operators, and then I was contributing stuff to Mutiny. And at some point, I remember I was willing to do some performance work. So I started to make changes to improve the performance. So it's the throughput, the allocation rate, stuff like that. And, inevitably the question came was how much money should we throw into making Mutiny fast? Like if we look at where Mutiny is going to be used, like to implement services, and you do this because you want to be efficient with the way you program with a non-blocking I/O. How much how much time should we spend making Mutiny fast, and at which point should we say we are fast enough given the context? So that's the main driver behind this paper, because we had to come up with benchmarks, because unfortunately there are no benchmarks in the reactive space. But you had to, kind of dissect what we were doing in Mutiny and compare with others to understand what's a good performance like.
And maybe one thing is that so Mutiny is a result of many other experiments we did over the last 5 years. Using different others reactive programming libraries and dealing with experience issues and developer experience issues. And when I started writing Mutiny or creating Mutiny, I didn't want to spend 3 years on it. So I said, okay, I'm going to go directly to what makes the most sense and remove all the fancy features that we can add later. And one of them was a lot of performance optimizations that I have seen in other libraries. And I would say, no, not right now. We will see later if we need it or not. And we make progress like that. And when Julien joins the team, it was like, okay, but all this choice I made to go to deliver something very quickly, to ship something for Quarkus, well, do we really have to revisit them? And actually, that's where Julien started his benchmark and so on, and he will tell us the result of this now.
Sure.
Yeah. And maybe just for the, because I remember when I joined Quarkus, which was about 2 years ago, and and I saw this thing called Mutiny. I was like, wait, why are we doing that again? Or like, because one of the things Quarkus does is like, hey, we're using technology who's proven itself out in the wild, and then try and fit it in. But with Mutiny is a bit, yes, we are using the same principles as a reactive, what do you call it, reactive programming. But you made a choice which I think was, I didn't see at first because I didn't have that much experience with Reactor. But now that I tried both, I'll say that and what you told me back then, Clement, was the big win here is that Reactor and the others has basically an API where every method is exposed on it. So you can get content assist for it, but you don't know which one is the right one to use in the right context. And they use a more functional convention versus Mutiny, where you've done it so that, hey, that you only get those that kind of make sense, and then you go in and then you get more focused help, which means there's less things to see. But at the same time, you also have some of the same names. Like you do have some of them in there. But the idea is that, well, I see your claim is by focusing on developer experience, you get a cleaner API. And then the hope was that, hey, the overhead of that. That's well, the claim is that we can still have that and still have a good performance, right?
So yeah, so first, user experience has always been a pillar of Quarkus, and so that's why we have panache. That's why we have this dev mode, continuous testing, and so on. And it's also applied to APIs. And the initial test we made around reactive programming was a little bit weird. We were recommending completion stage, so the API from the JDK, to avoid any other dependencies. And on the other side, we had a minimal set of operators for reactive streams. That is a microprofile specification that was named microprofile reactive streams operators. The issue is that, and we realized that very quickly, that the user experience was not okay. It was not consistent. It was too limited. It was not necessarily usable even by reactive developers. So we decided to just rework it. And during our Vertex time, because Julien did a lot of Vertex too, he even wrote a book about it. So
you should buy it.
I already have it. So, but we also learned that using regular reactive programming libraries is hard for most developers. Especially in our context, most of the developers are not necessarily functional programmers. They don't necessarily have the whole mathematical background to do this. They focus on doing things and getting it shipped and getting it right. And it's totally fine with that. And
emergencies?
Yep. I don't know, probably on my side, sorry.
What do you do now?
So, and the thing is, so when we realized that, I reward the API to have something much more navigable, as you said, Max, where you have groups of methods, so you know where you need to go, and you can quickly see the methods that are available for you in that context. We also provide a few functional idioms, not all of them, because we don't provide traverse, for example, or things like that. But we have map, flat map, and so on. If you really want to see to use functional, it's also possible. But yeah, all this choice comes with some costs, some allocation, some simplification in terms of chaining methods, or what we call operator fusion, that we don't have in Mutiny, and a lot of things like that I decided to not do when I started the project.
Oh, so Julien, do you want to share?
Yeah, if it works. So let me check. Share my screen. Looks good. Going to share the entire screen. I have nothing since critical to share. So do you see my screen, guys? Yeah?
Yes.
I think so. I'm going to go in full screen because it's always better. And yeah, can you see the slides? Great.
We do, yes.
Okay, great. So I didn't
Yes.
change anything. It's the original slide for the paper. And the video has been archived on ACM. So even when I'm dead in 100 years or something, the video will be there for my grandchildren. So that it's really amazing.
One thing is that the paper has been published in a scientific conference, so it's not necessarily an easy read, but you can definitely read it. It's not too hard. It's been checked by peer reviews, and all the results that have been presented are reproducible. So
yeah, so there's in the paper you can find the GitHub repository with the benchmarks, and we had so it's not never fully bulletproof, but we had three researchers reviewing the paper, so we can be we're confident it's sound enough from a scientific point of view. So yeah, I'm going to read you the talk. So first thing is, what do we mean by reactive? And it's a very good question to have. So for us, in the case of Quarkus and Vertex and what we do, the four of us, we are in the context where we help people build distributed systems, like distributed services, maybe gateways, maybe HTTP endpoints, it may be Kafka event processors, it could be messaging stuff, etc. So what we all know is that blocking IO do not scale, because when you have threads and you do blocking IO, which is the imperative programming model that many people know, at some point of time, you want to read from a TCP buffer, a TCP socket, or you want to write, then you're going to block the thread because you don't have enough data, or the write queue is full, so you need to wait, etc. So in that classic model where you have one thread for each new incoming connection, on one hand, it's very easy to approach because it's that imperative programming style that we all know and we are all familiar with, where you can have loops, you can have try-catch, etc. But the thing is, threads are not cheap. So threads consume memory, and if you have, and the more threads you have, because the more connections you have, you should not forget that the threads are going to put pressure on the kernel scheduler. So they're all competing for CPU time to be allocated. So we know that it's a simple model, but it doesn't scale, and it's getting extremely important today to write resource-efficient services, because it's very likely that you're putting your application in whatever language you like in a container, and that container is going to be collocated with other containers in a virtual machine which is running on hardware. But if you're in all these cloud-native environments, what you view inside the container in your process, when you see one processor, one CPU, you're actually seeing a virtual slice of a virtual thread. So really, it's really important to write resource-efficient services, because given some hardware that you have or that you pay for in a cloud environment, you really want to pack as much services as possible in what you have. So this is what we call deployment density, and it's really something which is key if you want to save money and be resource efficient. So you need these resource efficient services. So one solution, which is what we advocate in the Quarkus Reactive stack of Quarkus, is the combination of three things. So one thing is to go with asynchronous I/O, so non-blocking I/O, because the idea is that you can deal with many concurrent connections, but on a very limited number of threads. So instead of allocating one thread for each new incoming connection, you're going to have, say, 4 threads that are going to deal with all these concurrent connections. And you can do this because you're using non-blocking I/O, so you can multiplex concurrent connections on a single thread or on a limited number of threads. The second ingredient is to use back-pressured asynchronous I/O streams because you have asynchronous components talking to each other. So inevitably, you fall back into that problem of coordinating the flow between a fast producer and a slow consumer. So you need to have a flow control protocol, which we'll be talking in a minute, which is called reactive streams. And finally, you need because you're doing non-blocking I/O, you're going to have inevitably this continuation passing style of programming where you have bits of processing done in purely CPU that are purely CPU-bound processing. Then you do some non-blocking I/O, so you need to have a continuation, which at some point is going to be the next step in your program. So there are multiple ways to do it. You could be using callbacks, coroutines, future promises, reactive extensions. And in our case, it's what we chose. So reactive extensions, because it's fairly nice to have a declarative model to say which operators are going to process the events, and you can combine this with fault tolerance, etc. So it's a pretty interesting model. So if you combine these three things, you can have a model where you're doing asynchronous I/O. You have flow control, and you have a programming model to support the composition of the asynchronous operations you have to do. So that flow control protocol is called reactive streams. It's something which is, fairly simple when you look at it, but it's actually very complicated. So it looks very simple because you have only 4 interfaces to implement if you want to make a reactive streams implementation. So to begin with, you have a publisher, which is publishing events. And then you have a subscriber, which is going to subscribe to that publisher. When you are a subscriber, you receive events like the items, you get the errors, the completion signal, and of course, you get the subscription, and that subscription is being used to request elements. For example, you say, I want to get up to 1,000 elements. And you can also cancel the subscription to say, I don't want to receive anything anymore. I'm just moving on to doing something else. And you have also a fourth interface, which is processor, which is both a subscriber and a publisher. So it could be like an intermediary processor to filter elements or to transform data, stuff like that. So it looks very simple because it's only 4 interfaces in Java, but the able is really in the details, because while it's a very simple set of APIs, you have a very complex TCK to pass with many rules you have to implement if you want to be reactive streams compliant in your implementation. So in the TCK, you have all these rules like when you have multiple threads sending you events, you must serialize the events so you don't receive at the same time for multiple threads. There are rules regarding what you should be doing with the reference of your subscription, etc., etc. So it's really complex to do it right. So yeah, in the Java space, we have 3 libraries. Initially, so the first one was RxJava, then followed by Reactor, and more recently Mutiny, which Clément created. So the main difference when you are a user and you don't care about the implementation or the history of the projects is the developer experience. So what you have on the left is the kind of code you would be writing with RxJava and Reactor, and you basically get exposed to functional programming idioms when you want to compose asynchronous operations. So it means that you're going, for example, if you want to, you get an item from a message queue, and then you want to make a call to your database to do an insert into the database, then you need to remember that in functional programming idioms, it means that it's going to be the flat map operator. And if you do this every day, and you're familiar with and trained in functional programming, then at some point it makes sense. And you remember that flat map means I'm going to chain some asynchronous operations. But for many developers, it's quite complicated. And when you look back at code bases you wrote like 6 months earlier, it may be complex to read what you wrote with flat map of concat map single delay error stuff, etc. And something Clément mentioned in the motivation for the developer experience side of Mutiny. So when you're in your IDE and you're doing completion, you get exposed to more than 100 methods, and you have to know your way around all these, concat with bounds, debounds. So, many methods with overloads and functional programming semantics. So again, if you're familiar and trained in functional programming, great, but for many people, it's an issue. On the other hand, in Mutiny, we chose to be more verbose, to have a more verbose API. So for example, instead of saying filter, we're going to say select where and have a predicate. And then we have groups like onItem. And when you do onItem, then you're only exposed to the methods that are relevant to processing an item, like transforming to something that's an asynchronous operation, which is called transform to uni and merge. So we have a more verbose API, but it's not rooted into functional programming. The roots are in event-based semantics, so that it should be more readable to you. And yeah, so you have onItem, you have onFailure, which is here to help you express what you want to do when you have a failure. Like here, you can say, I want to retry with an exponential backoff and retry at most 5 times, etc. So that's, another philosophy of developer experience we have in Mutiny and Vertex and Quarkus. So inevitably, at some point, the question was, so because Mutiny is a newer code base, and very quickly we achieved a good performance level. We thought it was okay in the applications that people were making, but we questioned ourselves and said, how much more should we do to make it fast? Especially because we were not using some other techniques that the others, the older libraries were using. So we looked at, what kind of optimization techniques they were using, and we also looked at other metrics, like source code metrics, excluding, of course, documentations and tests, and just focusing just on the implementation. So in RxJava, for example, what you have is prefetching. So you have a protocol between operators so that you can prefetch data. Like you have a subscriber which is requesting you, let's say, 1,000 elements, but you, at some point, at some level in your pipeline, you decide that you want to fetch more because hopefully you hope that you will improve the throughput because you already prefetch some data from, say, I don't know, from a file system or message queue or something. So that's prefetching, which we do not support in Mutiny. The other, which, as we will see, has a small effect, is operator fusion. And the idea is to say that, some operators, like you select values and then you transform values. Sometimes you can merge these operators instead of having, more calls to be done on the pipeline each time you have an event. You may just fuse all these operators together, or when you confuse these operators, perhaps sometimes you can share some queues, because at some point, in pipelines, you may have some queues. So you may be able to share some queues, or you may be able to avoid some thread synchronization things at some point, etc. And something also we see in these libraries is what they call protocol relaxation, which means that for, in the case of RxJava, but it's the same actually. I recently discovered in Reactor, they had the same kind of relaxation. You say that between operators of the same library, you don't have to respect the reactive streams protocol because it has some constraints. So you can just say, I'm going to not respect the protocol because we are between operators from the same library. So these are all the kind of optimizations you can find in these libraries. And by contrast, in Mutiny, we're not doing any optimization. We're just stuck to implementing the Reactive Streams protocol, respect the semantics, and not do anything too clever until we have to do it. If you look at the metrics on the code basis, you can see that Mutiny has a smaller code base compared to the others. So it's less files, less lines of code, and drastically lower cyclomatic complexity. So all in one, it means that Mutiny, it may not have the whole, all these optimizations, but on the other hand, it's a much simpler code base to maintain because it's more cost effective, actually. So again, so there are no benchmarks in the Reactive Java ecosystem. So we could not take, some kind of pre-existing benchmark and say, we are going to compare Mutiny and the others in this benchmark. So we had to come up with our own benchmark suite. And then the issue is, so there are a number of issues, actually. The first one was we wanted to make sure that we would avoid all the JIT compiler pitfalls. So for that, we use JMH, which is the micro-benchmarking harness that you should be using. And if you need to understand, there's a good article at the Oracle Technical Network that I wrote like 10 years ago or something. But it really gives you the how to use JMH and how to avoid some of the classic pitfalls you may have when you write a benchmark and you get results that don't make sense because it's not what you wrote that has actually been running. And the other thing is we had to avoid end-to-end optimizations, especially because RxJava and Reactor, they have some operator-to-operator optimizations in the library. We needed to make sure that at both ends, so on the publisher side and on the subscriber side, we wanted to make sure that these would be library neutral elements so that we would just focus on measuring the performance of the pipelines or the libraries, but not being influenced by what's happening on the subscriber side and on the publisher side. So I'm not going to go through all the benchmarks. You can find them in the paper. I think it should be easy to understand, actually, if you read the paper. You can also find them on GitHub and see for yourself and running with different configurations, if you will. But yeah, I will show a few ones. So the first one is a micro benchmark for one-shot operations. So these one-shot operations is not part of the Reactive Streams specification because Reactive Streams is for streams. But inevitably, you need to do things like a database query, or you need to post a message to some stream or to some messaging system. And these are not streams, like they are just one-shot operations you need to do. So that's why in all these libraries, you have types, reactive types, that model one-shot operations. So in Mutiny, it's called uni. If you go to Reactor, it's called mono. If you go to RxJava, it's called single. So it's just to model just a one-shot operation. And in this case, we are doing a purely CPU-bound benchmark. So there is no I/O, no database query, anything. We're just measuring the raw performance and overhead of each library. And you can see that RxJava, which is not trying to follow some kind of reactive streams like protocol, is a little bit faster than the others, and then Mutiny and then Reactor by a good margin. And then just to put things in perspective, you have two baselines. So the one down below is the imperative, like it's just a for loop, during the transformations, and the other one is using completable future, because completable future doesn't have that kind of subscription-based protocol overhead. You just get a completable future, and then you can just change the operations but there is no notion of subscription, so that's why it's a bit faster.
So
Yeah.
Julien, just
Yeah.
when I saw this slide, the way I read this is why in Quarkus we don't only say reactive, right? Like if you have operation that's CPU bound and you're just doing some stuff, just use a blocking method. That's fine. Don't make it complicated.
Yeah, it depends what you want to get. The message here just to measure the overhead of using the reactive types. But then, yeah, depending on what you do, you may get, because this is not, there are no IO in the mix at this stage.
Sure.
So if you do anything which is purely CPU bound, for sure, you will get good performance with more traditional imperative styles of programming, compared to having something that has a subscription and you have operators that talk to each other, etc. But I'll also discuss it just not in the next slide, but the slide after, I think. But again, remember, it's only purely CPU bound stuff.
Yep.
Then you have the case of streams, which in the case of Mutiny is called multi. So you have a stream of many events. And in this case, you can see that the two code bases of RxJava and Reactor, which are, I would say, nearly the same code base actually, for historical reasons, they are a little faster than Mutiny, which can be explained because they have operator fusion. So they merge some operators, they relax the reactive streams protocol, and they get a slightly better throughput compared to Mutiny. So it's not a catastrophe, but it's a bit faster actually. And of course, you have another baseline, which is using the streams API from Java. So having streams, collections, and for loop. But the thing is, so we are in CPU bound cases, and that stream, if you use the Java stream here, I'm just using them using a single thread. Which means that if you're doing a computation and you can do stuff in parallel, then actually with, say, fork join or stuff like that, or just concurrent split operators, you're going to extract more performance than what you get here. But it's just to give you an idea of what's the intrinsic performance of comparing this stuff. Again, it's only CPU bound stuff, and if you're reactive streams, they were made for IO. So if you're doing purely, if you're processing in-memory data collections, it doesn't really make sense to use reactive streams anyway. And this is why we have, I'm going to show you only one IO bound case. But, we thought, so what happens when we actually do IO? Because if we did all this, Mutiny and reactive streams and all that, it's because you want to compose asynchronous. Well, you want to compose asynchronous programming because you have non-blocking I/O, and you want to have a very limited number of threads to deal with many concurrent connections. And that's what Reactive is for. Actually, you want to save money because you want to make resource-efficient services. And what we realized by doing this is that so in this example, we have a book which is being served over HTTP. You have 6 concurrent HTTP requests, and when all the requests come in, then you compose the results and you do something else, like you extract the body length, etc. And we realized that there's in practice there's no difference when you compare the when you do the same operation with all these libraries, and because you have IO in the mix, then and there's no optimization that you can see in IO bound workloads. And again, I may repeat myself, but if you go with reactive and reactive streams, it's because you want to do IO. It's not because you want to do something which you should be doing with, say, with fork join, for example. So yeah, that's really the key. Is there's no difference between all these libraries. So the TLDR of the paper. And this is going to be the conclusion, and we can discuss. The takeaways are, so if you look at the optimizations, you find in these libraries, they greatly increase the complexity of the code bases, which means more maintenance cost in these libraries. And by contrast, in Mutiny, we chose to have something which is simpler, and which is less costly to maintain in the long run. Again, I'm repeating myself, but reactive streams, they were made for asynchronous I/O. And if you're processing things in memory, then it's not what you should be using. So you have huge data sets in memory that fit in memory. Java collections are great. Imperative programming is great. Java collection streams, they can run in parallel for you. You have fork join, you have all that stuff, which is really, really made for doing concurrent parallel programming. And all these, and finally, the key is all these optimizations you find in the other libraries in the Java reactive space, they become completely futile if you put I/O, and that's actually what you do. So all these optimizations, they have no practical effect in I/O bound cases. They have a small effect in CPU bound cases for streams. Remember that Mutiny was faster than Reactor for one-shot operation in purely CPU bound cases. But yeah, again, if you do I/O, there's no difference. And that was the takeaway of the paper. I hope I made it approachable. And I'm going to stop sharing my screen. You should see a big.
I have a question, actually.
Yeah.
Like, for what you say makes a lot of sense to me, right? You want to do I/O. It doesn't matter how much CPU you're using, because you're going to be I/O bound. They're going to be slow. Those operations are going to be slow anyway. You're using CPU. Just don't use this stuff, since you're not going to gain anything. So if this is the case, and it does seem reasonable, and obviously you backed it up with all this, all these facts and reproducible data, why did RxJava and Reactor go to all this trouble of implementing all this stuff, right? If it doesn't make sense, which, like, even if you asked me before you wrote this paper, then intuitively I would have said, yeah, it just doesn't make sense. But so what gives there?
I can't blame anyone, actually. Perhaps we would have gone the same way if you didn't ask also these questions, like, what's our budget in terms of engineering and efforts we want to put in having a good library. We put the effort into having a good developer experience and having a reasonable performance, but we didn't want to put a huge engineering budget in having something which is as fast as you could, because we wanted to make sure it would be. I mean, fast has to be done in a context which is the context of what people are going to use your library in real-world projects. So I can't answer for the other projects, to be honest. Perhaps Clément has another complementary explanation. I don't know.
He's just been lazy.
Yeah, exactly. So that's the main thing. Why we didn't have those features on day one, because I'm just lazy. And no, it was clear. The thing is, I made Mutiny with Quarkus in mind. It was since day one what the goal was to be the reactive programming library of Quarkus. That brings you a scope. Because we were already working at that time on the reactive engines, so on native, Vertex, and so on. So I had something, I had a scope where I say, okay, so what we want to build, the vision for reactive application for Quarkus will be that kind of applications. Other libraries are much more generic. So it's harder to make such kind of choice because they don't have that scope in mind when they started it, because when they started it, things were really completely new. So it's not that they did it, it's mostly thanks to their work, we have understood that it will not bring much in our context. So this, with my laziness, hey.
The way I see it is that for what I asked is the classic case of like hindsight bias, right? In hindsight, it makes perfect sense, but maybe when you're doing it and you're like the first mover, like RxJava was, it wasn't a foregone conclusion, right?
So, but one thing now that I've read the paper, saw the video, and I've seen you do it again here. One thing I thought, like the whole argument of Reactive, well, not whole. One of the arguments is that it's not necessarily that the Reactive is each operation is the fastest, but it's that they can be interlead, right? So you can do some I/O while the CPU do some CPU when the I/O is going. So if you're saying that RxJava Reactor, are they better when you're doing in a mixed development? Because then the I/O is about the same, but they can save a little bit of time in the CPU intensive ones. Or because you didn't do that in the paper, right? Well, you only had CPU bound or I/O bound. Or was it mixed? I wasn't sure.
I mean, IO bound, maybe it's misleading because it's mixed actually, because you have IO in the, they are hitting a good share of time because you do HTTP requests, you do this and that. But then there is some CPU processing, like you get the book content and you need to extract the body length, which is the book side of the book, which is what you would do in a real world application actually.
Yeah, so you're basically saying as soon as you add I/O, no matter if it's pure I/O or mixed with CPU, all optimizations you do in the time library, in the reactive library, just doesn't show.
Yeah,
right?
Yeah, exactly, because I/O just take way too much time.
What is it? Amdahl's law? You guys.
Yeah.
I remember some stuff from university.
Great.
Well, you mentioned a few things that I think was interesting of stuff that I know we hopefully could get on Quarkus Insights in the future. Was that you mentioned that some of the other libraries did these, what do you call them, protocol, like operator fusions and protocol relaxations, because they're going to be the only library in town. But aren't we in a nice situation where, because there's both Reactor and RxJava and Mutiny, and there's probably going to be more, where you end up having multiple libraries active in your program? Then what does the Java ecosystem do then?
I think there are two questions. So yeah, the first one is a remark about the optimizations. So again, it's only between operators or the same library. So if you have first piece of your pipeline, which is in library X, and then you go to library Y, then the optimization are only in that teeny space, and then you have to bail out, and you don't do these optimizations because you can't propagate them to the rest of the pipeline. And the other side of the question, I don't think I remember.
So the other side is, as we all implement the Reactive Stream spec, we can interop. So we have some level of interoperability. I can consume something coming from Reactor, and RxJava can consume something I provide. So there is no problem with that. There is a few differences, but they are very, very small and should not be apparent for 99.9% of the cases. However, the fact of having multiple reactive programming library on your class path might be something people need to consider, because that will make your code base quite complicated very, very quickly, because in your team, maybe someone will develop in Reactor, someone in Rx, someone in Mutiny, and yes, they are all interoperable. You can merge it, no problem. But the maintenance of this, when you're gone, when it reaches production, who is going to learn the three libraries and the small differences between all these libraries?
Okay.
Not to mention that increased memory usage, right, from these huge libraries.
Yeah. By the way, one thing that when I initiate Mutiny, we already wanted to go native with GraalVM, and that was also part of the constraint I added myself to help the dead code elimination, to reduce the number of classes that you will have at the end, so not bringing too much things.
So we actually got a few questions here, and we run out of time. So one is this one: where can we find the slides? Those the one.
I guess you can find them on my website, or
if you put the link, then I'll.
Yeah, there should be, or I will add. I'm not sure I have them on my website. I'm not sure.
Okay.
But anyway, I will tweet about it. I promise.
There we
I
go.
don't just tweet
Okay,
about
and then
stupid
I
stuff.
have I think it would be a quick question and then maybe a long one. And this one is not. This is just a very specific one about how do you do disposable in Quarkus and Mutiny.
Well, we call that cancelable instead of disposable,
Yeah.
but
He's asking in Android, SK provides hooks in which you can clean up disposables.
yeah, so we have exactly the same thing. We have something called cancelable, and you call cancel. I believe disposable has a method called dispose, but it's mostly the same thing. Quarkus on various extensions does that for you. So typically, REST is reactive cancels when the connection is cut. Reactive messaging does the same, and so on. So we mostly have the same kind of things in various extensions. Now you can also implement your own what was it?
Cleanup. If you had some results you manage and you inject into your pipeline through events, you can react to the termination events, cancellation events, and then you do your own cleaning stuff. So it's all it's ready to do.
So basically, trying to be look for cancelable instead of disposable, and the method is still called dispose.
No, the method is named cancel.
Cancel. Yeah. And then these are fun one, right? So I'll get one from Mark here. It says a common complaint about RxJava is that it's quite an invasive API. It tends to push you to use Rx constructs, even in areas where you don't need one. Rx, how did you address this issue? Or did you even address this issue?
Okay, so it's a very good question actually. So it's not necessarily a Mutiny question; it's more a Quarkus questions. And in Quarkus, you can mix both imperative and reactive, and you can assemble your pipelines with both. So, and again, if you do CPUs kind of things, don't use Mutiny or Rx or whatever. Just use your regular code. It will be better. And just do the assembly if you need with the Mutiny or Rx. However, if you want to go in a really full end-to-end reactive pipeline, then you probably will have unis or multis everywhere. What I recommend is that if you have a piece of logic that can be extracted in its own method in a pure imperative way, do it, and then just inside your chain, just call that method. So you have your chain in one side that's on item, invoke my business logic, and your business logic method is separated and doesn't have anything to do with uni, multi, and so on. This is what I recommend. It seems to work very well because it creates a clear separation between your pipelines and your chunk of logic.
And I guess it's an inherent problem. It's not RxJava's fault. This is just Java doesn't have these constructs, so there's no shareable API in this sense.
We should all do some Swift,
Yeah.
And then come the one that always comes up when we have this. Any idea how much Project Loom will influence in the interactive libraries? Your favorite question.
Yes, we have. Do I have to be more specific?
I think so, yes.
Damn it.
Just talk about memory and stuff.
No. So, the thing is, Loom introduced virtual threads. It tackles the problem in a different angle by saying, well, instead of creating more operating system threads, which are expensive and so on, we will just create a few of them and then have everything a virtual thread. Okay, so that's a pitch, and then there is how it's done. How it's done is that you have a scheduler and you have the concept of threads. Each thread have a stack. These stacks are not small in in what we do today. So basically saying that it's cheap. Yeah, okay, it's cheaper than a process thread. For sure. Is that zero? No. It's clearly not zero. So then if you have enough memory, no problem. If you have unlimited memory, go perfect. The problem with what I'm seeing right now is that we're deploying in containers. in containers, you have a fraction of a virtual CPU and a fraction of memory. And in that case, it may not hold the promise that has been sold so far.
How does Loom compare to coroutines in Kotlin? Do they have the same issue, or?
Coroutine works on bytecode manipulation, so they rewrite your bytecode in a very smart way, a complicated way if you want to decompile it, which we did because we had to understand. Which say, why? Yeah.
Yes.
Loom goes inside the JVM to do that. So on one side, I would say it's simpler for them because they control the JVM, but at the same time, they introduce new concepts which might not be, which need to be explained. However, and that might be a good news, we will have some experimental things with Loom relatively soon in Quarkus. It's some work in progress. I can't commit on any date because there is still a lot of things that need to be polished.
We already know you're lazy, so yeah.
Yeah, so typically we are dropping the set of features we want. No, but yeah, we are taking Loom very, very seriously. We are going to integrate with it. But yeah, well, one thing that you need to understand is that it's not a silver bullet that will fix all your issues. That's not true.
I think what is important, and I think it matches what we said we had this question on Insight a few times, is like Loom is very interesting for people to avoid having to learn too much about reactive APIs and get into those pitfalls. But still with Loom, yes, you get better developer experience, let's say that, but for a price. And with Mutiny, you can kind of, hey, it's important for you to have a high density on your deployment, which is the case in cloud, etc. Then there's still a place for, let's call them traditional reactive libraries as it is today, right?
I'll call them legacy.
Legacy, yes, no legacy there.
You are the new legacy.
Yeah.
Now, something to keep in mind is that, to go back to Mutiny, Mutiny has a few set of operators which are await. So uni.await at most 5 seconds, whatever. And on multi, you have something called two blocking stream or two blocking iterable. These operators has been designed to be Loom friendly. So all our reactive APIs in Quarkus are Mutiny, and you can already use them in a Loom applications using these two operators, which will do the right things to not block what we call the carrier thread. So these few operating system threads that you must not block, because that's the same thing. It's not granted. There is still a couple of constructs that are not supported by Loom. So here we did it. I actually implemented them a few times to be sure that we are not blocking the carrier threads. So we have almost all our APIs which are Loom friendly. Now the only thing that need to be done is doing the Loom thing correctly.
So, but just to translate this, what it means for users is like, if you start using Mutiny today, then when Loom comes around, you can add some Loom code, and that will still fix it. You don't have to rewrite, and it's
exactly. So we have operators that will work perfectly well with Loom. So even if you use a reactive REST client and get a uni, and you want to call that in a Loom virtual thread, so you don't want necessarily the uni, you just do await at most whatever timeout you want, and that will work out of the box.
Okay, so in 6 to 12 months, we'll have an updated version of the paper about Reactive versus Mutiny versus RxJava versus Reactor versus Mutiny versus Loom, and then
why not? But it might be different measures because I want to look at something else. But just something to complement what Clément just said. So yeah, you can do. You have a bridge from Mutiny to blocking operations, which could be Loom friendly. Just remember that in Quarkus, it will complain if you try to block where you should not be blocking. Like if you're on an event loop because you're using, say, REST-easy reactive, and you block, it will just immediately crash and block and say, hey, you should not be doing this. Yeah. So it's a framework, and we give you some safety.
And
So-
I'll just. Oh, sorry.
So that's what I say. You must be on a virtual thread to do what I just explained. Or, you will get, hey, you're blocking the IO thread, and you are not allowed to do that.
So I'll just say that the same way that like we're reactive to the core, but like we support blocking or we support coroutines and everything else. We'll support Loom because like we have all the fundamentals in place, and we have the people with the knowledge. So when Loom comes around, we'll be ready for it.
So that doesn't mean that we will say that Loom is going to work in native. We have no visibility on that. But we can say that we will have some JVM support of Loom relatively soon.
Very cool. And we're on the top of the hour. So I'll say thank you, Julien and Clement and Georgios. We got some questions. And that's the end then. So thank you, guys.
And don't hesitate, if you have more questions, you can go to Zulip, you can ping us on Twitter or whatever.
GitHub discussions for me.
Or GitHub discussions,
Yeah.
or just send an email to Max, he loves that.
Yeah.
Go.
Perfect. Let's do that. Thank you.